Number 22. What's the oxidation state for a manganese atom? All right, we're going to be at a dance party now. You say atom, or I say atom, you say neutral. Atom, neutral, atom, neutral. Atoms are always neutral chemical species. Why? Because the protons equal the electrons. Protons being positive, electrons being negative. They have equal magnitude of charge, just opposite signs. So when you want an atom, I often call this in my course a standalone, and they're going to have a zero charge. The other charges you see are called oxidation states that are listed on a periodic table in the upper right hand corner of MN. These are the ones they can like to be. So do not look at this question and look it up and say, oh, I saw +3, +7. I saw these charges, okay, in the upper right hand corner. These are the charges they like to become, okay? They're talking about an atom. An atom's protons equal the electrons. That's why if you ever want the electron number of an atom, you find the atomic number, okay? But in any case, this is an atom, and you say neutral. Therefore, the atom's charge is 0. Standalones are 0. Okay, so 22 is 1. And as an aside, to identify a redox reaction, look for a 0. If you got yourself a reaction, let's say, I'm just making this one up, and copper chloride, and I want to make aluminum chloride, and copper. If you can find yourself a 0, a standalone element, you know you have a redox reaction. That standalone can exist as an element like this, or it can exist as a diatomic element. So that's important you realize that, because once you find a 0 on one side, it's not a 0 when it bonds, and therefore its oxidation numbers are changing. And just like number 21, we just talked about, electrons must be passed around. So another way to identify redox reactions is find atoms in your reaction, find the zeros. 22 is 1.